Welcome to The Explainer. Today, we're diving into a brand new story of the universe. It's this incredible idea that connects the tiniest particles we can possibly measure with the absolute largest things we can see out in the cosmos. And it suggests that two of the biggest puzzles in all of physics might not be separate problems at all, but actually two sides of the very same cosmic coin. Okay, so our story really kicks off with two incredibly strange clues that have scientists completely scratching their heads. One of them comes from a particle accelerator right here on Earth, and the other, well, it comes from the very edge of the observable universe.
So this first clue comes from the Alpha G experiment over at CERN. For the very first time in history, scientists were able to measure how antimatter actually responds to gravity. What they did was they took anti-hydrogen atoms, the antimatter version of hydrogen, and they essentially just dropped them to see what would happen.
And the result was, well, it was absolutely stunning. The anti-hydrogen did fall, but it only accelerated at about 75% the rate of normal matter. Now, I can't overstate this. This is a huge deal. The weak equivalence principle, a cornerstone of physics for over a century that says everything should fall at the same rate, well, it might have a huge crack in it.
All right, so that's clue number one. Clue number two takes us to the complete opposite end of the scale, way out into the farthest reaches of space. Using these incredibly powerful telescopes like the James Webb, we can basically look back in time and see the universe when it was just a baby.
And what we're finding out there just shouldn't exist. We're seeing these massive, fully formed, mature galaxies that, according to our standard model of cosmology, simply didn't have enough time to form. It's kind of like finding a full-grown oak tree where you're pretty sure you only planted a seed yesterday. You combine that with other weirdness, like the conflicting measurements of how fast the universe is expanding, that's the famous Hubble tension, and it really starts to feel like our standard story of the cosmos has some serious holes in it. So to really get why these new clues are so disruptive, we've got to talk about the reigning theory of the universe. It's called the lambda-CDM model. Now that's lambda for dark energy and CDM for cold dark matter. For decades, it's been incredibly successful, but it also comes with some pretty serious baggage. You see, this model basically works by taking Einstein's beautiful theory of gravity and then adding a few extra totally mysterious ingredients to make the math line up with what we see. We have to invent dark matter to explain why galaxies don't just fly apart, and we have to invent dark energy to explain why the universe's expansion is speeding up. They're basically just placeholders for stuff we really don't understand. And as the physicist Dragan Hajdukovic puts it, adding all these separate patches just to make things work, well, it feels like we're moving away from the kind of simple, elegant explanations we expect from fundamental physics. So the big question is, could there be one single, more elegant explanation for all of these strange clues?
And this, my friends, is where our story takes a really radical turn. It brings us to a brand new theory that proposes a single solution to all our cosmic mysteries. And it all comes down to the very fabric of empty space itself, something called the quantum vacuum.
You know, in modern physics, we've realized that empty space isn't actually empty at all. It's this seething, bubbling ocean of so-called virtual particles and their antimatter twins, constantly popping into existence and then vanishing again in the blink of an eye. You should think of it as a real state of matter, just like a solid or a gas, but one that's everywhere all the time.
Okay, so here's where this new theory, called quantum vacuum cosmology, makes its big move. It starts with a pretty wild idea. What if these virtual particle-antiparticle pairs are also, in a way, tiny gravitational magnets? One end has a positive gravitational charge, the other has a negative one. Physicists call them gravitational dipoles.
So what does that mean? Well, normally, the quantum vacuum is just this chaotic mess of randomly oriented little dipoles, right? So their total gravitational effect just cancels itself out to zero. But, and this is the key, when you introduce a massive object, like a star or a galaxy, its gravity polarizes the vacuum around it. It forces all those tiny little dipoles to line up in the same direction.
This aligned or polarized vacuum then creates this invisible halo that generates its own gravity, seemingly out of nowhere. And this, right here, is the key. So let's see how this one single idea could connect the dots between that particle accelerator experiment and those galaxies at the edge of time.
And this slide just perfectly illustrates the elegance of this new way of thinking. Instead of needing three separate hypothetical patches for our model, dark matter, dark energy, and this thing called cosmic inflation, quantum vacuum cosmology says, hold on, maybe one fundamental mechanism could explain it all.
So, how does it actually work? Well, first off, that halo of polarized vacuum around a galaxy would create extra gravity. To an astronomer looking at it from far away, it would look exactly like the galaxy has way more mass than it actually does. This effect perfectly mimics what we've been calling dark matter for all these years.
And suddenly, all the other pieces just start to fall into place. Those impossible early galaxies, they could form so fast because every single atom of gas in the early universe had its own tiny but powerful halo, creating way more gravity than we thought was there. And the universe's accelerating expansion? The theory says that's just the large-scale combined effect of all these polarized halos pushing against each other, literally stretching the fabric of space.
But wait, because the theory doesn't stop there. It offers a truly stunning and elegant solution to one of the biggest mysteries of all. Why is our universe made of matter, with almost no antimatter anywhere to be found?
Okay, get ready for this, because it's a pretty mind-bending possibility. The theory proposes that we might be living in a cyclic universe. Our universe, the one dominated by matter, it suggests could have been born from the collapse of a previous universe that was made almost entirely of antimatter. So here's how the cycle would supposedly work. First, a universe like ours expands. Then, the immense gravity from all that polarized vacuum eventually halts the expansion and causes everything to contract and collapse. In the final, violent moments of that collapse, the insane gravitational field creates enormous amounts of new matter and antimatter right from the vacuum itself. But here's the twist. The theory predicts that the matter falls into that final singularity, while all the newly created antimatter gets violently ejected, kicking off a brand new universe. It's just a breathtaking idea. The reason our universe is made of matter is simply because the last one was made of antimatter. So, look, quantum vacuum cosmology is still a very new and developing theory, but it really challenges us to reconsider everything we thought we knew, from dark matter all the way back to the Big Bang itself. It suggests that these strange clues from the smallest particles and the largest galaxies might actually be pointing to the same hidden reality, leaving us with one last really provocative question. Thanks for joining me for this explainer.